Your assignment is the following. Watch the video and take notes. And complete the following problems. In your textbook, page 420 through 421, numbers 14, 16, 21 through 26 even, and numbers 27 through 29. All of them. We already know a lot about the Pythagorean theorem. We're all able to say that a squared plus b squared is equal to c squared. But really, let's talk about what that means and what else we can do with it. The formal definition of the Pythagorean theorem is that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. We've used the Pythagorean theorem before to find the length of a missing side. So if we had a right triangle, we knew that this was 14, we knew that this was 9, we could find out what that missing side was. By solving for x squared, squaring our terms, we could find the value of x, and in this case, the square root of 115 is approximately 10.7. But what if we looked at the converse of the Pythagorean theorem? The converse of the Pythagorean theorem states if the square of the lengths of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So what this is really saying is if a squared plus b squared is equal to c squared, then it's a right triangle. Just like we've previously done, we start with our familiar a squared plus b squared equals c squared, but this time I'm going to add a question mark because we're not sure if it does equal c squared or not. We're going to substitute the largest value, which in this case is our 17 centimeters, for c, and we're going to put the 12 squared plus 9 squared on the other side. So in this case, when I add 144 plus 81, I only end up with a value of 225, not 289, which is 17 squared. So this triangle is not a right triangle. But what can we tell about this triangle given the information that we know? So looking at this, we would be correct in stating that 225 is not equal to 289, it's less than 289. We can use the fact that 225, which is the sum of the squares of the legs, is going to be less than 289. We can use that to prove some more things about this triangle. So the first case that we have is if the square of the length of the longest side, which we always call c, of a triangle is greater than the sum of the squares of the lengths of the other two sides. So if c squared is bigger than a squared plus b squared, then the triangle is obtuse. So for example, the one that we just looked at, 225, is smaller than 289, so 289 is greater than the sum. So this triangle is actually an obtuse triangle. Our second case is if the square of the length of the longest side of a triangle is less than the sum of the square of the other lengths of the other two sides, then the triangle is acute. So if c squared is less than a squared plus b squared. So let's look at an example for that. If we have a triangle with sides of 9.6 inches, 20.1 inches, and 18 inches. So take a moment, pause the video, and find out what c squared and the sum of a squared plus b squared is. So when we find the sum of 9.6 squared plus 18 squared, we find that actually it's greater than 404.01, which is 20.1 squared. So we actually find that this is an acute triangle. And of course, if they are equal, then it is a right triangle. Here's another example. Pause the video for a moment and complete it. So since we get c squared bigger than a squared plus b squared, we know that this is an obtuse triangle. Now you have enough information to complete your homework. Good luck!